Welcome to edupediaworld.com. You're watching the videos on quadrilaters. So in this video we'll discuss some more questions related to midpoint theorem, so which are very important from the exam point of view. So you have to watch this video very carefully. So let's discuss. The question number 1 says that in parallelogram ABCD we have E and F are the midpoints of side AB and CD respectively. We need to show that the line segment AF and EC, means this line, trisects the diagonal BD, means we need to prove that this equals to this equals to this. So let's see how we can prove this. Now first of all we need to write given. It's given that ABCD is a parallelogram and E and F are the midpoints Now so first we need to prove that AECF is a parallelogram. So first we need to prove AECF is a parallelogram. So let's see how we can prove this. Now since ABCD is a parallelogram, so if this is a parallelogram and it's given that E and F are the midpoints, so we can say that AB equals to CD, and we can also say that AE is also half of AB since E is a midpoint. Similarly, we can say that FC is also half of CD. So since AB and CD are equal, so we can say that AE equals to FC, right? And we can also say that AE is parallel to FC. So one pair of opposite sides are equal and parallel, so it's a parallelogram. So we can say that AECF is a parallelogram. Now if you consider this triangle DQ and C, so consider triangle DQC. In this triangle we know that PF is parallel to QC. Why? Because AECF is a parallelogram and F is a midpoint. It's given. So we can say that P is also midpoint of side DQ, or we can say by converse of midpoint theorem. So which says that if line passing through the midpoint is parallel to the third side, so it also passes to the midpoint of the another side. So we can say that DP is equals to PQ then. So let it be first. Similarly, now if you consider triangle, let's say we can say this triangle A, B and P, we can write consider triangle A, B, P, then also we can say EQ is parallel to AP. Why? Because AECF is a parallelogram and E is a midpoint. So again we can say that Q is also midpoint of side BP. Why? We can say by converse of midpoint theorem, right? So we can say that BQ equals to QP. Now let it be second. Now if you see first and second from 1 and 2, let's say we can say that from 1 and 2 we can say that DP equals to PQ equals to BQ. So we can say that now the line segment AF and EC trisects diagonal BD since all the three parts are equal. So this is how we can prove these type of questions. So let's discuss the next question. Now the question number 2 says that show that the line segments joining the midpoints of opposite sides of quadrilateral bisect each other. So let's say if we have a quadrilateral like this, A, B, C and D, so let's say these are the midpoints. Now if we join these segments, so we need to prove that they bisect each other. So let's say this is P, Q, R, S, and let's say this is O. So we need to prove that PO equals to OR and SO equals to OQ. So let's see how we can prove this. Now if we can join these parts, let's say these lines like this, okay, so it will be another quadrilateral. Now let's say if we can prove this quadrilateral PQRS as a parallelogram, then we can say that the diagonals bisect each other in parallelogram, so we can prove it easily then. Now so let's see how we can prove it. So let's draw the diagonal AC first. Now if you consider triangle ACD, right, so in triangle ACD, S and P are the midpoints, right? Now if S and P are the midpoints, now what happens is, if this according to midpoint theorem, if the line joining the midpoints of the two sides of a triangle, then that line is parallel to the third side and it's also half of the third side. So we can say that SP will be parallel to AC and SP will be half of AC. We can say by midpoint theorem, right? Now so let it be first. Similarly, if you consider triangle ABC, in this triangle again R and Q are the midpoints, right? So we can say that RQ is parallel to AC and RQ is half of AC. So by midpoint theorem, right? So let it be second. Now we can say that from 1 and 2, we can say SP is also parallel to RQ and SP is also equals to RQ. Now we can say that then PQRS is a parallelogram. Why? Since one pair of opposite sides are equal and parallel, so it's a parallelogram then. Now since PQRS is a parallelogram, so we know that in parallelogram, in diagonals bisect each other, right? So we can say that PO equals to OR and SO equals to OQ. So this is how we can prove these type of questions. So let's discuss the next question, the question number 3. The question number 3 says that ABC is a triangle right angled at C. So let's first draw the triangle first. Now let's say this is a triangle and it's right angled at C, right? And then a line through the midpoint M of the hypotenuse AB and parallel to BC, means let's say this is a midpoint and this is a hypotenuse. So this line parallel to BC, so this line is parallel to BC, intersects AC at D. So let this be D. We need to show that D is a midpoint, so we need to show that D is a midpoint. Then MD is perpendicular to AC and we need to prove that CM equals to MA equals to half of AB. So let's see how we can prove this. Now since if you can see that MD is parallel to BC and M is midpoint of AB, then we can say that D is also midpoint of AB by converse of midpoint theorem. By converse of midpoint theorem. So which says that the line is parallel to the third side of a triangle and the line passes through the midpoint, so it will also pass through the midpoint of the another side of a triangle. So we can say that D is a midpoint of AC, right? So we can say that then AD equals to CD. So we can say that this equals to this. Now the second part, we need to prove that MD is perpendicular to AC. Now so since MD is parallel to BC, and we can say that then angle C equals to angle ADM. Why? They will form a pair of corresponding angles. We can say that this angle equals to this angle. They are pair of corresponding angles. Why? Because these two lines are parallel, and this can be AC, can be the transversal. So we can say that then MD is perpendicular to AC. So this is how we can prove the second part. Now the third part, we need to prove that CM equals to MA. Means let's draw this line first. So we need to prove that this line equals to this line. Now let's see how we can do this. So if you consider triangle ADM and triangle CDM, then we can say that MD equals to MD. It's a common side, right? And we can say that angle ADM equals to angle MDC, each 90 degree. And we can also say that AD equals to CD. We have proved that M is a midpoint, right? Then we have three conditions: one side and included angle. So we can say that triangle ADM is congruent to triangle CDM by SAS, right? So we can say that CM equals to MA by CPCT. So congruent parts of congruent triangles are equal. Now since M is midpoint of AB, then we can say that MA is half of AB. So now we can say that CM equals to MA equals to half of AB. So this is how we can prove these type of questions. So let's discuss the last question of this video. The question says that ABCD is a trapezium in which AB is parallel to CD and BD is a diagonal and E is a midpoint. So this side equals to this side of AD. A line is drawn through E parallel to AB. So this line is also parallel to AB, intersecting BC at F. So we need to show that BF is also midpoint. So let's see how we can prove this. Now first of all, consider triangle ABD. Now in this triangle, EF is parallel to AB, or let's say this point be O, or we can say that EO is parallel to AB and E is a midpoint. Then we can say that O is also midpoint of side BD. Why? Because of converse of midpoint theorem. So we can say due to converse of midpoint theorem. Why? Because converse of midpoint says that now if this is a line is parallel to the third side and the line passes through the midpoint of one side, so it also passes through the midpoint of the another side. So we can say that O is a midpoint also of side BD. Now again, if you consider triangle, let's say BCD. Now in this triangle, we can say that OF is parallel to CD. How? Let's say we can say that EF is parallel to AB. So we can say that OF will also be parallel to AB. Now AB is parallel to CD. So we can say that OF is also parallel to CD. So this is how we can say that. Now since O is midpoint. We have proved. It's proved above, right? So then we can say that F is also midpoint of side BC, right? So this is how we can prove that. Why? Because why is F is also midpoint of side BC? We can say because of converse of midpoint theorem. So this is how we can use the converse of midpoint theorem to solve questions. So thank you once again for watching this video on edupediaworld.com. So keep watching further videos. Have a nice day.